But that's what this shared sequencer is going to become. If this shared sequencer needs to be aware that there's all these applications running in these things to integrate it on whatever intent-based thing it implements, now you are a monolithic chain that's just calling out to external services. So you're going to run into the same scale boundaries that whatever the sort of things have.
Yes. Agreed.
So what did you gain other than you're still using Ethereum? At some, like 3 layers down the stack, there's an Ethereum node somewhere.
Here we go. We're back. It's been a while.
Yeah, long time no see. It's been a few weeks, actually.
Yeah, I'm not sure what happened exactly. I just noticed this slow, like, just every week I realized for some reason it wasn't going to happen this week. And then that continued to happen.
Yeah, I think you had a trip and you had a trip, then I had a trip, then something else happened. And then it's been long enough that I recall you actually forgot if we had uploaded the previous one.
Yeah. But I mean, this all speaks to the professionalism with which we approach recording podcasts.
Definitely. We do need to fire writing stuff, right? Since our scripts seem to be all over the place. But
what about our editor? Our editing is sometimes very choppy.
I don't know, man. I think it's all the wine. He's just like kind of a bit of a mess, that guy. For the next one, it might be a jet lag.
Yeah. In some ways, it's good that it's been a while because actually there's a lot of interesting stuff that's happened. We have a couple interesting topics to dig into. Of course, everyone is now starting to enter the full, what should I call it, bull market mania. I literally just tweeted yesterday, like, it's weird, there's no mania, Bitcoin is almost at all-time highs. And then people started texting me, like, should I be buying Bitcoin? I was like, fuck. Man, so I'm gonna wait, to hear from some childhood friend's long lost sister about which crypto they should be buying this cycle.
Yeah, someone was asking me about this, I think a couple weeks ago, like a civilian, let's put it that way, was asking me about crypto a couple weeks ago.
Not an active duty.
Exactly. Someone completely uninvolved in the usual trench warfare that the last year has been was asking me about it. And I'm like, okay, things look like they're picking up. Things are picking up, I think, earlier and faster than I would have guessed. So we'll see.
But I mean, what I do find really fascinating about this time around is I don't think we've ever gotten to previous all-time highs with this little fanfare. Like the previous all-time high has always been, I'm not saying like that's peak mania, it's not. Peak mania is like after that, but it certainly has always been like this big milestone that everyone is like incredibly excited about. And now it's kind of like, ETF flows, whatever, like Bitcoin.
Well, look, I'm not entirely sure that it has sunk into people that were into most civilians again that were approaching it. If you notice, like the last 25% bump or something has been in the last 3 days, right? So
yeah,
it would surprise me. People just wake up tomorrow and go like, wait, it did what? Start going nuts.
Yeah, but so I don't want to stay on the price topic too long because I do think like what I would like to do with this episode is to counterbalance all the price talk to some extent with all the actual interesting stuff that's happening on the technology side. And there is actually interesting stuff. I'm very excited. But I do find it very interesting to see what happens, given that this is, from an interest rate standpoint, a very different environment than we've ever had before in a bull market.
Yeah.
And like what I would have assumed is that the bull market would be quite severely tempered by the interest rates. But then if we're at all-time highs already,
or almost. I mean, we're recording this on February 29. We're a little bit below that. We are above the highest monthly close of Bitcoin ever had, but we're not
right.
at ATH yet.
Well, okay, whatever. It's one candle
Yeah.
that we're waiting on, but like it is interesting. There's kind of this question of like, where will this money come from? And one argument quite possibly is that it comes from the ETF. Like, who do the interest rates hit the most? The kind of like middle and lower middle classes, I would imagine. But then the rich people still have money to throw around, and they've been watching this thing on repeat for over a decade and losing out on what degens would call gains with a Z. So maybe, but regardless, I think it'll be very interesting. Like just to paint a hypothetical, because it's an interesting thought experiment. Like if the cycle sort of broadly stays the same, which it obviously may not, it's impossible to predict, but if it does, then what does that sort of communicate to the world at large? If the cycle just keeps going regardless of the interest rate environment, I think that's like a fascinating thing. You could obviously argue that the government are going to pump stuff and stocks are doing pretty well as well, and so on and so on. So like maybe the high interest rate environment isn't quite what it's marketed to be. But anyway,
Okay, I'm not going to say anything more because otherwise we're just going to stay on this topic. But we can return to it at some point, or we're not going to get to tech, which is by and large not happening on the Bitcoin side of things anyway.
Wow. Now that you mention it, so I mean, let's get on to the topics we wanted to discuss. But I will say that I think there's been more movement on Bitcoin tech in the last 6 months than there has been in the entire history of Bitcoin. I've talked to 4 or 5 projects building Bitcoin rollups in the last few weeks.
Okay.
We'll see how that all works out.
I'll be curious to hear about that. I would say that more development in the last couple of weeks than in the last 6 years is not saying much, right? If I have a penny and I find another one, now I had twice as much money. I'm not rich, but
there's the like interesting part of this, and I think this is what's driving a lot of the change, is that there is a seemingly growing subset of the Bitcoin community that is getting louder and louder, who want Bitcoin to evolve technologically. And I think that is a very interesting dynamic. I've basically written off Bitcoin for a long time, primarily because in my mind, the community was completely unwilling to change, which would result in it being largely uncompetitive in the technology race. But to be clear, like still Bitcoin Core, is doing whatever Lightning bullshit, and yeah, like we're still far away from it being the shining light of innovation that some people would want it to be. But anyway, moving on. Arweave put out something called the AO computer, as in like the letter A and the letter O computer. And I think it's very exciting. Do you want to give a quick overview of what it is and what your thoughts are, and then I can do the same?
Sure. I'm probably going to be going at this for a bit because I actually spent a little bit of time today kicking the tires. And by the way, credit to Arweave. A few episodes back, and in fact, a few times we have asked each other, like, what the hell is going on with Arweave? Doesn't seem like anything is going on. And Apparently, there has been quite a bit going on because
Yeah.
they just have been doing it. They just have been doing it quietly, which kudos to them, right? There's projects that go at things quite the opposite way, over promising and over delivering. I, if you had told me that Sam Arweave's founder had just bought an island and moved there and was doing whatever, I wouldn't have been surprised. Apparently, that has not been the case. So,
He
Teemu
seems
sent
quite
me.
engaged.
Yeah, that would definitely be the term. And well, let's first talk about AO, then we can ramble about it before we're accused of being Arweave shills. So the way that Sam promoted on this video, how he describes it, is basically a hyper parallel computer. It was a really funny description that they did, because they basically compare Ethereum to the processing capabilities of a TI-80 calculator, which I'd never thought about it in those terms. It's quite accurate. And Arweave came up with this approach, which is basically purely message passing between processes that can be hosted anywhere, which in theory would allow it to scale basically to whatever the heck you want or to whatever the heck you need, because you're not doing any shared processing of anything nor operating on any sort of shared ledger, effectively.
Well, okay.
Yeah.
So
Go ahead.
the a lot of this message passing is specifically operating on a shared ledger, right?
Well,
Like there,
up to,
you can operate on shared state, and you can message pass between these different processes, but these go through Arweave, and so you are constrained by Arweave performance for that.
okay,
But because
that
you
is true.
can, but you can like the so sorry to jump in. Let me give kind of like the um how I understand it. So there's this concept in the data availability world, in the Ethereum world, called sovereign rollups. And the idea with sovereign rollups is that you basically have like a rollup that just works with itself. Kind of, it doesn't verify the anything on Ethereum. And this concept has been taken by the data availability layers as like, okay, you could do this on a data availability layer where you just use the same kind of data platform. I've always thought that was a little bit funny because you need persistent storage. And it would all just be much easier if you had persistent storage. And so I've always wondered why people didn't just use Arweave or Filecoin for that matter.
Asterisk there is that I wouldn't consider Arweave a global ledger for what it's worth. I mean, if we look at the structure, you don't necessarily, if you're running a node, you necessarily need to keep the whole state of it, right?
Yeah, sure. Yeah. But like globally, the probability is that the whole state is kept, right?
If we talk about the network as a whole, yes.
Yeah, exactly. So whatever the case, like this is sort of like a similar structure to me, where you can think of these like external processes as like a log of things, and those and the logs can be put into Arweave. I guess they don't have to be put into Arweave, but certainly for anything where you have communication between different processes or these logs, or you have a like shared state object on Arweave that you want to touch, then you would be constrained by Arweave, and you do need to wait for finality in the sort of traditional blockchain sense to do a lot of that. But what I think is potentially really exciting is if you get very granular control over like what needs to be like what specifically needs finality or touches shared state, what's okay to just get kind of like pretty loose ordering, what doesn't need to be
Indeed.
on the ledger at all. Like there's a spectrum of things that I think allows you to potentially like scale in a very different way than we've seen. The one thing that I would point out though is that like I think looking at AO, like I don't think you can take like existing decentralized applications and use those like to understand what you can do with AO, because you can build like a Uniswap potentially on it, but that will largely have the same kinds of constraints as Uniswaps in different other circumstances. It's more like there's a much greater universe of possible application types that can be made, and that is facilitated by the scalability in terms of being able to decide what goes kind of on ledger and what doesn't.
And just for what it's worth, it's not even just loose ordering. I mean, unless the architecture has changed, there is no ordering per se in Arweave. It's just I store this piece of content, and this other 5 pieces of content are supposed to be the reference, but that's just because they were pre-existing. There's basically no particular ordering, the transaction ordering sort of way of this happened after that. The messages in AO do have a signature, but and a time that they were sent, like a timestamp, but that's about it. You necessarily need to consider it in that sense. But yeah, the messages that are passed are basically stored currently in Arweave. And in fact, since you talk about the application types, if anyone listening to this is not from the crypto side, you may actually have an easier time understanding this than people who are crypto people. In fact, the easiest way of thinking about Arweave, I think, about AOS is kind of like Erlang, which is
is that the easiest way? Just imagine Erlang for the average person. Like, this is the explain it like I'm 5.
No, for the average programmer. I don't mean average person.
Okay.
Because I think Erlang is one of the oldest, one of the oldest stateless message passing focused programming languages that I can think of, and that is what they're doing. It's basically you send a message over there, that thing sends a message back. The end. If you want to look at it more modernly, you could basically think of it as a bunch of processes communicating through something like RabbitMQ, or any other messaging queuing service that you want, and up to the point where, in theory, you could implement the things that handle these processes in any language that you want. In fact, Simon Video talks about plugging the SVM if you want, Solana virtual machine, and there's a team. He mentioned, I don't recall the name, that's working on adding the Ethereum virtual machine to this. I guess because there's a user base out there, right? But on their tutorial, you can.
Let's discuss that just to sort of clarify. So, if you want to add the SVM or the EVM to this, what does that mean? That means you run some process. You basically run the EVM external to Arweave, right?
That's what I would expect.
Yeah, and then what?
You wouldn't necessarily. Okay, so the
you
stuff
post,
that
you post the execution traces to Arweave.
That's okay. Pause there. For starters, the tests that I run were on AOS, which is their AO operating system. I am not entirely sure if this is the case, but again, going back to the old-timey references here, AOS seems to be pretty much a dumb terminal for the compute users, the compute units that are running somewhere. In fact, my AOS instance seemed to be mostly communicating with a CU in San Francisco, if it is correct.
There were some kind of incentives for the CUs, right? Like you paid them for.
I would imagine you do. This is on the testnet, so I haven't had to, pull up any R units for it. I would imagine you need to, given that you're sending a message that says store this thing somewhere so that the CU can take it up. Okay, so if you were going to, on the Lua tests that I run, you do need to create some message handlers. Basically, you're going to start a process. That process is going to get messages. If there is nothing that handles the messages, you just discard them. if you were going to add the EVM to something like this, I would expect that you would need a way to hook up some methods to handle some specific things, right? Or they're probably going to implement the equivalent to a contract that is the message receiving contract, and maybe some message sending functions as well. I would expect that's what they need to do, but I haven't gotten that deep yet.
Well, but you could. Well, if you know where the messages are coming from, you can just read that data. But if you don't, then yeah, you need some kind of like endpoint or a contract.
Yeah,
for the messages to come to.
I'm not an Ethereum developer. I would imagine that they're going with whatever feels more familiar for an EVM developer. So.
Yeah, but I was mainly curious about this because, like, okay, I can run an EVM locally anyway. What exactly do I need Arweave for?
What do you mean? What do you need Arweave for on this thing?
Yeah. Yes. So, like, why would I want to run an EVM in AOS? And this is what I was getting at. Like, I understand there are a lot of applications that I think are exciting. I don't understand why you would want to run EVM.
Oh, I would imagine again that you're just doing that to show that you can, and because this, in theory, opens it up to Solidity developers. It's not how I recommend people go about it. I mean, Lua seems to be, frankly, much better for writing this sort of thing than Solidity. So, and AOS does support Lua as the basic scripting language.
Yeah, an EVM is all entangled shared state, so you would have to do all of that on Arweave. And you would
not
need a lot
exactly.
more stuff.
You would
Well, you can have many local instances who update their local state based on messages on Arweave, but I'm saying because it's all shared state, then like in practice, it all needs to be on Arweave. You see what I mean? Like everything is a message, and thus like everything needs to be on Arweave.
Depends on how you do it again, but yeah, I haven't looked at the implementation.
I mean,
basically anything that exits, I would imagine that anything that exits the contract will end up on Arweave, because that would be the message response.
Yeah, but it's, in EVM, there's no like everything exits, right? Like unless you, I mean, you can do just your EVM stuff on your own, but like every single EVM application would kind of exit the contract.
Okay, again, I don't think anybody expects that you're going to get Uniswap and run it on this thing.
I wouldn't be so sure. I wouldn't be so sure.
Okay,
you would be surprised by how many people expect to get Uniswap and EVM in every which place. Anyway, let's maybe go into more like what kinds of use cases are interesting to deliver on this. So, I mean, you probably have some ideas. One like very obvious kind of one, which is almost could be like a default thing, is just chat. Like, not saying that's necessarily a great like business case, but more like what is a chat besides like a bunch of local logs that sort of synchronize messages.
Look, on anything that is actually the ideal thing that I would think fits this is something for which you would want some of the security guarantees that public blockchains have of, I know that this is going to be executed in a certain way, because there's in theory some contract staking that they mentioned on the introductory video. I haven't looked into that to see how that is done, if it is done yet. So you would want to have that sort of thing, but while having the possibility of unbound computation that you don't have on any of the current general purpose blockchains, let's say, because either Ethereum is limited by basically gas, Solana is limited by this needs to finish executing within a slot, preferably, plus whatever CU units you throw at it. Given that this given that whatever you execute on AO would be running on a compute unit somewhere, and I imagine that if you have compute units handling certain types of messages, or running something that handles certain types of messages, you can put it up on a machine of whatever size you think is appropriate. Then anything that requires significant processing, you could get through this. Anything that requires reaching out to the internet for arbitrary data, you could get through this as well, right? There's an example of an Oracle application that they mentioned on the video, which I also haven't looked into. That's a trivial case. But for instance, if you want something that runs an application summarizer, a text summarizer, and sends you a result, that would fit both of these criteria, right? It needs to feed off of external sources. It needs to have relatively unbound compute, because you don't know if it's going to end in milliseconds or it's going to take a few seconds to finish. So you could do it through this while having the verifiable execution side of things as well.
Yeah. What is, like, I really want to try and figure out like a great example of something that wasn't possible before. And I don't immediately have one for it.
For a while, you've wanted to. Okay, let's think about it this way. This is another approach. On regular blockchains, there is no transition. Nothing happens unless somebody executes the transaction, right? This pushes the state forward, which means that you're not going to get basically anything that pushes data back at you, or that executes something, or that waits for an external result and pushes data back at you. This is something that you could do on iOS. You could just send a message to a process, subscribing to something that polls for a result, and that lets you know, or that pushes pushes a separate process forward once that thing happened. That you couldn't do on Ethereum. You couldn't do on any of the current state machines that I can think of.
Yeah, so cron jobs are definitely interesting.
Triggers.
How do you get verifiability on that though? Like, so, like, let's say that you have a whatever. What are the parties called? The compute units.
You have the compute, you have the messaging unit, and you have the scheduler, basically.
Yeah. So like, how do you, if you have like, okay, send me a message if X happens, how do you get any kind of guarantees around that, is kind of my question.
That is where we get into the contract staking thing that they mentioned on the video, which I haven't looked into on if that is documented or implemented yet. There's a staking blueprint on their guides, but I haven't gotten to it. I started looking into this like a couple hours before we started recording.
Yeah. So I like, maybe another. So let's just come about it from a slightly different direction, which is that I think, like, in general, having a persistent data storage system as your base layer is very interesting. We've discussed this before with Filecoin subnets. In fact, I think Filecoin subnets are kind of like in a similar direction, right? Like, they're sort of trying to achieve the same thing. They're just proposed in this more blockchain-y like way. While Arweave, of course, in classic Arweave style, completely ignores how people think about things in the blockchain world, and start doing all kinds of random shit. I do think this is probably a more elegant kind of implementation of it, if they can figure out the guarantees. I think the guarantees are generally the tricky part, because they usually require some kind of verifiability that's asynchronous to some degree, unless you want like the whole consensus to participate in that, which you don't, right? Because it kind of undermines
it defeats the purpose of this.
Yeah. And so And so like what I'm really curious about is like whether they will sort of inevitably, in order, so like it seems like what they want to do is build like the base structure and not define the guarantees, at least not unless they absolutely have to for some functionality, and then let people build up their own guarantees in other ways, which I think is the smart way to do it. But I wonder if this inevitably goes into the world of zero knowledge proofs, when you need to start proving that something has been done correctly on an external machine.
And this might be the approach that you mentioned, actually, letting every application define their guarantees, because on their guides, the staking thing is a blueprint. It would seem to be this is how you would go about building this. But again, I haven't really dug into that part yet, so I don't really want to talk about it.
Yeah, and I mean, there's only really like there's only three ways. There's only three guarantees you can get for some external execution. There's a trusted guarantee, which is that Intel says that this is what happened. There's re-execution, which is what most blockchains employ, where you just have everyone do the same thing and they get to the same result. Everyone's happy. And then there's zero knowledge proofs. You could argue there's also the optimistic thing, but that's basically a re-execution, or like a more optimized, not even optimized.
It's not.
It's a re-execution fallback guarantee in a way. And they have different dynamics, but broadly speaking, like optimistic is still re-execution, because like you do need to, if there's a challenge, you need to check, and the way that you check is with re-execution right now. You could also check with zero knowledge proof, or like a verify zero knowledge proofs. But anyway, so given that dynamic, it seems like sort of like if they want to do like verifiable things, then they would almost have to employ zero knowledge proofs, or the builders of applications would have to employ zero knowledge proofs, which is pretty interesting. But then there is also something that was probably heresy in blockchain land, which is like, if these are consumer applications, maybe you don't need that much verifiability. Like maybe it just needs to work, right?
And in
so
a lot
like
of the
it's possible
cases,
that a lot of like, if you like, you can kind of imagine it as a kind of subnet, in a sense, where you can have like some application, and the sort of application developers run the entities that do all the external compute and receive payments and so on. It just uses Arweave and AO as basically a computer, right? Like,
yeah.
computers don't give you guarantees by default. It's just a computer. It can do these things. This is the instruction set, like that kind of level. And it's hard to see exactly what the use cases would be, but one that comes to mind, which I think might be quite good, is social media. So I think in social media use cases, and there are a lot of attempts to do decentralized social media in different ways, I think they're all firmly in the MySpace era or earlier in terms of progression. Like, if Facebook is the final thing, then maybe it's not even MySpace. This is like Usenet shit or something like that. But social media has like this interesting dynamic where you don't need it to be fully trustless. That's not actually what people want. In fact, it's kind of harmful for it to be fully trustless, because that basically introduces costs with every interaction, which fucks up UX. what you do want though is that you want that data to be somewhere where you can publicly access it at any time. Um, and potentially tap into it from a large variety of different applications. Um, and for things like that, maybe this would work because you like one constraint that all these decentralized social media things have is that like it's just really hard like to do video and photos and things like that because none of them can be stored on the blockchain where they're built. And so, for example, Lens actually uses Arweave as a backend um, for their data. Um, and so, if you just store your like whole social graph, you store all your data in one place where it's publicly accessible. You maybe don't care that much if you're using a trusted intermediary, as long as it's actually getting to Arweave, right? Like you don't need like verifiability necessarily on the fact that like it was put there because you can go check yourself, like the end user application can go check whatever.
Yeah.
There is some compute involved in that where you probably do ideally want verifiability unless you're doing it locally. For example, the algorithm that is generating your feed or whatever, you either want to do that locally and have sort of some control over that, or you can outsource that compute and then you want some kind of verifiability. But that might be like the type of thing that this could facilitate, where you sort of like where you have like a big use case that's not purely financial in nature, and so the required guarantees look quite different than in traditional blockchains.
That's what I was going to bring up. That one of the reasons why you want that verifiability on blockchains is because, by and large, everyone's money and value is in the same place. So it is very important to figure out that if value moved from A to B, it's because it was supposed to. The more interesting applications that I see for this thing are not actually would not fit that. And in fact, when you were talking about this, I realized that there's a domain that I'm really interested on that I should have thought of the moment that I heard this thing, because it actually fits the three criteria, which are basically potentially unbound compute, or at the very least, a situation where you can be sure of when you're going to get a result. It likely requires message passing, and it requires potentially to be push driven, like you can do with this and not with blockchains, which are autonomous agents. So you could, for instance, trivial scenario, suppose that you want to have something that you task with figuring out the travel itinerary for you, right? On a blockchain approach, that you would need to assign value to this thing. Say, here's a few $1,000 that this thing then needs to assign and buy tickets or what have you via verifiable criteria. That is delicate, of course, because now you have a process that has your cash, and who knows what it might do with it. But you don't even know when this planning might complete. On something like KOS, AO, you could basically just have something that sends a message to the planner. Eventually, at some point, you get a message back with a plan that fits your criteria, and maybe all the necessary steps to execute on acquiring the required tickets. But that thing doesn't need to have access to your keys, doesn't need to have access to your money. It's just the thing that you control that gets back the planner, and the plan and verifies it, that actually ends up doing the financial disbursement if you so wanted to. So you basically don't have the financial risk of having this value assigned to something that is completely outside of your control, running on some CU somewhere. So I don't know. I find this sort of like autonomous agent case quite interesting, and I don't think you could do that on Solana or Ethereum at all.
Well, I mean, you can always stand up a a server, right, and just have that execute instructions.
Certainly, but at that point, you're standing up a server somewhere. This is closer to a decentralized Lambda approach for this thing. Well, even though Lambda functions are supposed to return quickly as well, so not necessarily even qualifies. So,
Decentralized Lambda requires some kind of verifiability for compute.
no, it doesn't.
Why not?
This is effectively what it is, what AO is. You don't necessarily need to verify it. As you said, you could just trust the result. I trust that
you can just trust the result, yes.
Particularly in a case like the travel planner, like you could go out and verify that this is the optimal plan that fits your criteria, but why is that a requirement? You just could look at it and say like, yep, looks good enough. And maybe you're paying $10 more a night for a particular hotel that you would otherwise, but
well, let's see what happens. I think this is one of the more exciting things that I've seen in a little while. I think it's always exciting when there's exploration sort of like outside the usual bounds of blockchain. The blockchain industry like does all kinds of super interesting things, but at the same time it is very like constrained in its mental model of how things should look. And I think that stems from exactly what you said, where like it's sort of designed to handle people's money, and that has a set of requirements that are quite different to like many applications. Like a computer doesn't have those same requirements in the same way. Those same requirements apply to like your banking infrastructure backend, but not to your computer per se. And so there's some like middle ground there, which I think is very fascinating and interesting to explore. But this is a good segue into another topic in the blockchain land, which is actually very tangential to some extent, and that's Rollup Abstraction, or Justin Drake from the Ethereum Foundation has been going around talking about rollup fragmentation and the solutions to that. This is coming at it from the other side, which is like the solution is some kind of rollup abstraction. So this is a super fascinating debate. There's kind of like, I'd say, two camps. And I mean that in the loosest way possible, because there's like, these are barely even groups of people. There's like me and some other guys, and then like and then Justin Drake and some other guys, kind of thing, where like these camps are like probably not even really aware of each other. Like this is not like big blocker, small blocker debate or anything. But I think it's going to get there very quickly, because right now, so there's this obvious problem in the Ethereum ecosystem and the Ethereum sort of scaling roadmap in general, which is that when you visit your local MetaMask wallet and you click on the drop down, it's getting longer and longer, the network drop down. And if we're assuming like that the scaling roadmap's whole purpose is to sort of have this near unlimited horizontal scaling of rollups, which is there's a lot of words in there which are questionable, but like let's just take that as an assumption. Then what ends up happening is you completely fuck up the user experience for most people. So like already you have this situation where there are environments which you can use in the Ethereum ecosystem, which perform very differently, have very different cost structures, et cetera, et cetera. But the vast majority of users are never going to figure out how to navigate there. It's a complicated multi-step process. You need to bridge, like how do you need to understand the security assumptions that you're bridging under, et cetera. I would venture to guess in sort of a classic blockchain narrative thing that like the vast majority of users are not aware of the security assumptions underlying the bridges to these rollups, which tend to be multi-sig. Multi-sig meaning there's some group of like 10 or less people who decide whether you get your money or not. And
not to mention that unlimited horizontal scalability through multiple rollups basically also means unlimited vertical scaling of that particular dropdown in MetaMask.
Yes, exactly. And so there's this security assumptions, which is slightly a different topic. Like, I don't want to get into that. That mainly revolves around like how do you get forced exits on chain, and that's one topic. But we don't need to go into that. The more interesting, I think, topic is how do we improve that user experience? And I think the way to do it is basically we need to abstract away the rollups to some degree. We need to make it so that the user does not need to know what exactly is happening on the back end. The analogy I use is like you don't need to know which microservice, some service you're using is currently running some task on. You want to comment?
No, keep going, because I'm curious about how you're gonna suggest they go about this, because given that these rollups have, let's forget about the security assumptions, as you said. Just like the cost structure is different, and what response times you can expect out of that is different. You don't necessarily expect microservices to behave in that way either. You just as something you get a result back, but you literally don't care about what happens in the background. With a rollup, you kind of do, if nothing else, because of the cost.
Yeah, and this is part of kind of like my argument. So I'll give you the sort of lay of the land. There's like kind of like three different strategies that are being attempted or employed in different parts. One is this sort of like interoperability network of some kind that's layered on top of the rollups. So this is like basic message passing. I know. Ricardo's making faces and laughing. But this is like there's a lot of different variants of this, so to point out one thing, this is not like an absurd idea. The question is how decentralized can these be made to be, right? Like an exchange, a centralized exchange is essentially an interoperability system for different blockchains or rollups.
And if the majority of the rollups would actually, or all of them would agree to a central, to the same general layer, or if you're going to end up with the same situation where you actually now have multiple overlaying layers to implement against.
Yeah. Yes, exactly. So the doing this in a decentralized way, things get quite a lot more difficult. But essentially, it's the same problem as we have with different distinct blockchains, where they all have different stacks. Getting these things to talk to each other is not simple, and like even if you can do it, it's like it's a new. Every connection is a new integration in two directions. And so that's just a huge amount of work and complexity to manage. So you end up in a situation where you have like, I would call these some kind of like bridging or interoperability protocols. They always serve, like there's a ton of them and they serve some subsets of the use of the space, which actually doesn't kind of help, because then you need to use a different one for whatever place you're going. And then there's stuff like Layer Zero who are kind of trying to abstract that away, and whatever. So that's one approach to this. I think the likelihood of that succeeding is very similar to the likelihood of that succeeding on blockchains like L1s, i.e., did not succeed. I like people use Wormhole, and that's kind of how it goes, right? And even though like even that is stupid, it makes no sense. You just have this like weird wrapped version of the token on the other side that you need to trade into something else. Like it's absurd. And they're all distinct depending on like which bridge it is that you're using and whatever.
Distinct meaning different liquidity expectations as well.
Yeah. And so then you need a market maker who's willing to essentially provide liquidity for wormhole ETH against, probably whatever native asset is on that chain, and then against another, bridge, whatever. So quite inefficient in many ways, a lot of complexity. The other approach, which is the Justin Drake and like Espresso Systems approach, is essentially that we need all rollups to use the same shared sequencer. The idea being here that a shared sequencer can do sort of like cross-chain things because it sees all the different sides of that and it talks all those different formats. Justin Drake has further suggested that Ethereum L1 could be that shared sequencer, which I think is somewhat absurd. Look,
I'm going to need an explanation. I'm going to need an explanation of the rationale about why all these things that exist because Ethereum can scale are going to use Ethereum as the shared sequencer.
Yeah. I don't think it makes a huge amount of sense, but so like but let's ignore that for a second and just focus on the idea of a shared sequencer. So like this is ostensibly a viable way of achieving abstraction, is if everyone just uses the same sequencer system. It's not like a solved problem by any means, but certainly you can imagine that there could be collective pools of liquidity. You could potentially abstract away a lot of stuff by doing that. The issue with this strategy in my mind is that first of all, in order for that to actually happen, every rollup needs to hand over their sequencing to some external system. So they retain no control over their own liveness properties. They don't control their stack. They don't control their like MEV properties. You have this like weird game theoretic thing where it's like, why would the Starknets and ZK Syncs and Aztecs of the world use some shared sequencer where they give up their point of control? And then you need to pay this shared sequencer network in some way to get it done. And so you're also like removing a relatively significant kind of use case for your token being the gas token. You can still have a token and use it to pay gas, but in practice it's kind of just a proxy for the sequencing. And then it's also on an implementation level, you just need to like actually integrate with the shared sequencer system. They're not going to support every possible format that people have imagined. And so like I think the viability of that is actually like there's just a lot of friction and game theoretic issues in trying to achieve that. And then finally, the last model, which I'm an advocate for, is basically the kind of Cosmos and Polkadot approach to rollup abstraction. And what I mean by that is that I don't think we're going to get to a situation where there's Ethereum and from the user's perspective there's just one rollup and there's like all these rollups under it. I don't think that's achievable. What I do think is achievable is that there's a couple primary rollups which abstract away the user experience within their sort of system of rollups. So you can have, let's say that you have like Starknet, you could have many Starknet rollups that manage to abstract away the user's experience between those rollups. So you don't need to necessarily move between these rollups or do anything like that. You just kind of scale compute horizontally in that way. And this is something that NIL is, I think, primarily pushing forward with their ZK sharding thing. There's,
I was going to bring
to be
them
clear,
up.
to be clear, there's a lot of unsolved problems here as well. Like you need to have some kind of shared state. It's unclear, like, do you just introduce all the problems of sort of sharding, or can we separate things in a way that works? Like, can you have your like balances on, you know, one roll up and then have services on other roll ups and you just interact with these services? Maybe all this does just introduce latency to the equation because there's something else happening besides the standard execution environment. But that at least is like kind of like, if you think about it from a market perspective, what always seems to happen in crypto is you have people who want to create a standard, and they create, and like Polkadot and Cosmos have achieved a kind of standard, but it's still an island within the broader ecosystem. Like everyone's not going to integrate IBC, you know, like it's not happening. And everyone is certainly not going to pay, you know, parity for being a parachain. Those similar structures to like Polkadot and Cosmos are certainly possible, where you just have like efficiencies from having a standardized stack. I'm not sure if you can fully abstract away that from the user, but at least you can get to much better UX where you can move around very easily, and like there's better, like you don't need have a completely different security assumption for every bridge you use and whatever. So I think that's kind of like a likely outcome of this, which actually means that the big roll-up players, they're all working on their own kind of like stack. There's the ZK stack for ZK Sync. There's the Starknet stack for Starknet. Nil is doing their thing. Polygon is doing their, I don't know, what do you call it? Like entire universe of every possible variation of roll-ups and validiums.
And we have yet to the
yeah.
episode where we say we had to discuss the Polygon strategy.
Well, I mean, yeah, but the Polygon is in an interesting position because weirdly, I think it looks kind of like an underdog right now, which I wouldn't fully have believed in some ways. Like if you look at their market cap, I mean, this is the POS chain, of course, trading at like almost half of Celestia, almost half of Starknet. Like it's kind of surprising.
But we have discussed this, right? If you just look at the POS chain, there are easier things to benchmark it against. Celestia, that was the benchmark when it came out, so the market caps can get wonky, and people would look at Polygon and say like, well, look, Arbitrum is doing all this stuff, Polygon isn't doing that much. I'm going to value that thing more. So it's
Polygon is doing a lot, but it hasn't launched a lot. This is kind of, I think, the part of the thing. So
sorry. When I said slightly jet lag, when I say it's doing this much, I mean has all this TVL and is doing this much volume. Not it's actually building these things, because Polygon does seem to be hacking away on a whole host of things, but as you say, they're kind of like a bunch of work in progress. It's almost like the cartoon of the programmer who keeps leaving empty and half unfinished projects around. Sometimes feels like that.
Yeah, I mean, but on the flip side, there are a lot of people deploying Polygon ZK EVM Validiums, so like single node rollups, like a lot. I have no idea what the fuck they're going to do with them, but there's a lot of them.
But let's come back to the mode. So you're saying this is the third mode.
Yeah. So I think those are kind of like the three overall strategies. I don't think there are very many others. Like maybe there's something along the lines of we just like ZK make like an aggregate proof of all the different proofs and then magic happens. But like like that will likely not look that different.
I don't know, man. I haven't given this that much thought because I've been kind of like arm's length from the Ethereum ecosystem for a while. quite frankly, I'm gonna go full Solana shell, and I think that something. If you basically all these things seem to basically be doing like a gigantic shared state with extra step, just trying to shove that down Ethereum's throat, basically. And I get there's a lot of value there, and I get there's a lot of developer mindshare there, but like for instance, I can see how you could use any of these approaches to solve the issue of is this actually USDC or is this some wormhole wrapped USDC thing that may or may not have liquidity, right? That these things would solve that issue for whatever for if you want to run and if you want to operate on an application that's running on one of this on one of these chains, but not on the other rollups. So that will solve it. I still don't see how this would solve the issue where you end up with, say, you want to do a token swap and there's more liquidity on a pair in one rollup than in another. This is not just an issue of sequencing. This is an issue of actually making a decision of where you want to execute, which is very much application specific. Which I guess gets us, this is what you refer to as the usual sharding problems.
But you can, so if you have a shared sequencer, you can approach it like, with an intent-based system where the user just defines the boundaries and the sequencer basically matches from across a lot of different things.
You can, but at that point, you need the sequencer to be aware that on these chains, there are these applications running that it can interact with,
yes,
right? So
means
at that point, the sequencer becomes an aggregator that needs to keep up to date with the state of every freaking chain that integrates with it.
Exactly. It needs to run a full node for every single chain it supports at the same time.
And it needs to be aware that they exist, right? It's not like the sequencer. If I deploy, I don't know, a pancake swap clone on my rollup that I just plugged into this thing, I may integrate with the sequencer, but the sequencer doesn't know that my pancake swap clone exists, right? So it's like you're buying yourself a two-way integration. It seems, I don't know, it really seems like way too complicated for something that faster chains already solving.
So faster chains are solving it, but like there is a cap, right? Like you can only scale a monolithic chain so far. Like, and by the way, I mean, as you know, I'm fully in that camp. I think in this cycle, like monolithic wins easy because it's just
But that's what this shared sequencer is going to become. If this shared sequencer needs to be aware that there's all these applications running in these things to integrate it on whatever intent-based thing it implements, now you are a monolithic chain that's just calling out to external services. So you're going to run into the same scale boundaries that whatever the sort of things have.
Yes. Agreed.
So what did you gain other than you're still using Ethereum? At some like 3 layers down the stack, there's an Ethereum node somewhere.
So, well, this is exactly it, and this is my problem with that strategy. And then like you can't sort of outrun, like you can optimize, right? So if like let's imagine that the Ethereum L1, the only thing it did was verify proofs, take whatever like call data stuff, or like the data blobs for verification, and then sequence. Like by specializing, you could make it more efficient at doing those things, and you probably would see some scalability benefits over something like Solana sort of in aggregate, simply because you wouldn't be doing a lot of executing on chain at all. But like, does that make sense? Like, or first of all, is that the case right now? Definitely not. Is Ethereum ever going to become that? Probably not, because its ability to change is severely hampered. And then you do have this like issue in the end, which you're describing, is like you just go back to being a monolith. Um, and that's sort of a dynamic of shared sequencing. And you blow up your hardware requirements like a motherfucker, and like you have this issue of okay, like if I'm a new Rollup and I want to get started, like will the shared sequencing protocol nodes want to also run my full node? Like how much money do I need to give them for them to do that, et cetera, et cetera.
Look, for
So
me, just the fact that I don't see a way to do this generically, again, where if you do want to do this intent-based thing, you're going to need to know what those sort of things are running.
And you can do the
that
intent
by
thing outside of protocol as well. So it's
sorry, say that again.
you can do the intent-based stuff out of protocol as well. You don't need to do that at the sequencer level. You can just do that like with external sort of workers.
Yeah, I guess.
Which is how it's currently being implemented, right? So
how do you verify those?
You just have it like you kind of like, for example, so this mainly works on like an exchange model, but you can define like, okay, I'm willing to buy at this price, this much, whatever. And then anyone can just come and offer that. So you kind of create an incentive for people to do arbitrage across different things. So you don't necessarily need that to be in protocol. But
fair enough.
But so this is exactly the case, which is why the sort of like islands make sense, because that does actually scale something, in the sense that you take on new kinds of trust assumptions, but it's like quite close to the original chain, or you have this sort of like one ZK rollups. Basically, the moment that the proof has been verified, you have sort of base layer security on the things that have occurred up until that point. And so I think that makes sense, and you can do a lot of clever stuff within those islands. But that doesn't actually like but you don't actually get out of the problem of like, okay, there might be an ever growing number of these rollups. But I think what you do get is that you do start having network effects within those islands, like you have network effects in Ethereum L1 right now. And so you do get this power law kind of thing where like, okay, there are tens of thousands of chains, but like how often do you go past page 1 of CoinMarketCap, like
Yeah.
And then sort of they don't matter that much. It's just noise.
You know what I think we need here? I think we need an Ethereum shell to come and sell us on this approach on a call. Basically, like somebody who's completely drank the Kool-Aid, who thinks that there's a reason for this inverted pyramid that balance on top of a baseball or something. That would love to get that sort of view, if you can think of anyone.
I mean, I can. I don't think they would want to come talk to us, though. But
okay, of anyone who would be willing to have us beat the thing with a stick.
But I don't think the idea of rollups is dumb. I think it does make sense. I think there's just this like, again, like any criticism I kind of levy against Ethereum L1 is not so much because I think they've done anything wrong or in a stupid way, but rather because like there's just a huge amount of friction to do anything. You make any in protocol change and you basically break all the applications. Like, and so like it makes sense. It's very difficult to do things. The issue with a lot of the rollup structures right now is that they are dealing with problems that are not necessarily problems like in the absolute. They are problems relating to the Ethereum implementation as it currently stands. And like the simplest, dumbest example is like if Ethereum was not a smart contract platform, but was instead just like a purpose-built thing to handle only the things that the rollups need it to do, it would be a lot more efficient and a lot more performant. Like this is obvious, right? Um, Beyond that, then yes, you would need to start compromising on security or whatever to make it more performant. Beyond that,
Sure, man, if wishes were
but
ponies, it's look. This is gonna come across as I have nothing against rollups. Some of my best friends are rollups, but
wait, so let me just close the thought there. So the point is, like, I think the roll up construction is not dumb, and is in fact a very interesting sort of like counter to like we are full monolith, because it is very like the idea of being fully monolithic and fast as you possibly can, and the idea of having rollups are at odds, right? Like you can't do both effectively. um but I think both should be tried. I certainly like there are plenty of examples from computing history that support the idea that constructions that look a little bit like rollups should emerge at some point and allow you to do new kinds of things. And arguably, like the AO thing is in that direction. Like it's
ah,
it,
bit different,
no, no,
and
no.
that is
From a pure like conceptual construction standpoint, so you don't have verifiability, which is a requirement in rollup, so they look a certain way. But if you just have this idea in your head of you have like threads or logs or processes, whatever, and some of them need to touch the base layer in some way. In Ethereum, the requirement is that everything needs to touch the base layer and be verifiable. But like construction wise, the idea is the same, right? So you can move compute more and more to the edges, and get a lot more scalability.
not quite the way that I see it. The way that I see it, and this might just because I like message passing as a means of communication as a whole. It was always for me the cleanest way of any interprocess communication. But the way that I see it, what basically you're discussing with this whole thing is a better bridge, and but it's still a bridge of sorts. Whereas the AO thing is much closer to de-bridged, where basically you just send the message from here to there. You make sure that something happened on both ends. That's it. You don't need any other sort of assumptions, except you sending a message and something taking it on the other end. So it is a lot. There is significantly looser coupling between everything else than on the message passing approach than on any of the three options that you discussed. And I agree with you that rollups as a whole, per se, like I have nothing against rollups per se. It's just like this trying to get all these rollups unified for me almost seems to defeat the purpose. I really suspect that you're going to end up running into the same constraints on whatever does the unification. Frankly,
You
for me, the
you
main.
you don't want to unify all of them, right? But you do need to improve UX. So there's a spectrum. So yes,
I
full
agree, and I think that
unification, you have monolith,
I
but
agree, and
like
I
there's
think that
some
the
middle
best way
ground.
to achieve that is just having a massive rollup die-off, and you just end up with a couple, three things that are clearly
Well, this is the
differentiated,
big
and
couple islands, right?
yeah, that's and the massive die-off is what I see as a much more likely path going forward. You're likely to get a winner takes most. At the very least, a winner takes most for a particular vertical, and somebody who wants to do something that fits that model uses that thing, and somebody who wants to use something that fits this other model uses this other thing. That's, I think, would be a lot saner than just trying to pretend that all these things are the same.
I have a question. Let's move on. I have one last quick thing at some point here, but they just this is a segue to a segue. um, um, what do you think? What do you think the optimal message passing layer looks like?
Oof. Interesting. I hadn't thought about that in those terms. I would actually say that a message passing layer needs to be as dumb and as simple as possible. There was this I think it was I can recall if it was a TCP IP design guiding principle, but I believe it was, which was um, something like be flexible and on what you accept and conservative on what you send out. So something exceedingly simple like Arweave that does focus on just retaining the stuff that you send without having to worry about what it is, and then something else can decide how to get it, would definitely fit that criteria.
Do you need persistent storage if you only use it for message passing?
You actually need persistent storage up to a particular window. Arweave defines itself as creating the permaweb, right?
Do you know what you've just described? Data availability networks.
Sure.
2-week storage. Arguably more optimal for message passing if you don't need historical messages. And in the Arweave case, you probably do want historical messages, but I
That's the
think
thing.
you do have this situation where if like the vast majority of your process is out of protocol, then you can't rebuild that process purely from Arweave data. You only get like the global view on it, right? You need to have the other
Yeah.
side of that
Yeah, that's the thing. I could
or
see.
something.
I mean, this is not what Arweave was designed for. We were designed to game theoretically have permanent storage of everything that is sent there, or at the very least to incentivize the possibility that at least one node will keep a piece of information out there. But I could see a version of and the way that we did this is that I think these numbers may have changed. Again, I haven't looked at the protocol details in a bit, but about half the payment was to whomever mined the actual storage, and then some of the rewards are saved for future disbursement to when someone else confirms that they're still storing this by using the message as one of the routes for a new one. So that's why nodes tend to keep things, or well, that's why nodes are incentivized to keep any piece of data around until the end of time, because you never know when it might be the root for something else, right? Now,
Yeah.
I could also see an update to this where when you send a message out, you say, I'm just paying for availability of this for a month, right? Because this is how long I care for this thing to be kept around. And then that reward gets spread out in a shorter amount of time. And then after that, no one's incentivized to keep it around. They might, but they're not incentivized to.
But do you think mostly the use cases will be processes that run out of protocol that use Arweave just for message passing, or processes that actually store all their data on Arweave and do message passing on Arweave? Because all their data on Arweave would seemingly be a more simple model and more kind of like it's just always there, right? Like it's not on your laptop. You don't need to think about storing it. Like you can access it from anywhere, kind of thing. Um, but then that is constrained by Arweave performance in very many ways. But my point here is this is what I was talking about, like loose ordering, which is not the right word, by the way, or the right term at all. It's just the first thing that came to my mind. But so, like, if you have this process and Arweave is super cheap, right? So, like, it's not like you could run this process, locally on your computer. And whenever you have messages, then yes, you would like those would get pushed to Arweave. And then at the end of your session, it would just like dump the state on Arweave, for example. Um, and in that way, like it's always there. And you actually use Arweave for the whole thing versus having this like completely external process, which like I'm not as sure of the use cases for that.
Okay, so for what it's worth, on everything that I have seen in AO, the Arweave side is completely abstracted away. Like it is clear because of the way that AOS behaves that even assigning a value is a message that is even assigning a value to a or not a variable, let's say to a constant, to a literal. Assigning a value to a literal is a message that gets sent to a CU, but the Arweave side of things is completely abstracted. So
But is everything a message?
everything that I
Everything is on
have,
Arweave.
everything that I have done with it so far has been a message. Yes.
Okay. Yeah.
So
So
again, on okay, specifically on AOS, on AOS,
yeah.
you could build your own application that just runs as a .NET executable and it keeps its own variables. But on AOS, everything that I have assigned or done or modified is a message. I expect because, as far as I can tell, AOS is not a compute unit on the network. It's just a dumb terminal to access a compute unit somewhere else.
Okay. Last thing, this is going to be a huge bombshell. We have something good to say about Avalanche.
Yeah.
What a day.
And actually, this is an interjection that I wanted to mention when you said that nobody is going to want to pay Polkadot priority for a parachain. At the rate things are going, we may end up saying nice things about Polkadot like 3 episodes down the road. But by all means, go ahead and say nice things about Avalanche.
Yeah. So I mean, just to riff on that, I do want to say, like, we hate on projects sometimes when they do things that we perceive to be dumb. That doesn't mean they're not building useful things as well. And like, it always makes me very happy when a project that has been doing things that I perceive to be dumb, when they do something useful.
I
So
think that
what
generally speaking, we crap on dumb things. We don't just crap on projects. It just
Yeah.
some projects seem to have a controlling interest on dumb sometimes.
Yes. And to be fair, also, like, if you're like a 10-20 billion project and you don't yet have product market fit or a use case, I can see how you might start to try some dumb things, like like that's a lot of pressure to like figure something out. But anyway, so Avalanche, as far as I know, I'm not sure if this is public yet, but I've heard from people who are in the know that they're dropping the requirement for Avalanche subnets to validate the main chain. So the way that Avalanche subnets has worked until now is basically like you define your own consensus stuff in the subnet and whatever, but all your validators in that subnet need to also validate the main Avalanche chain. And they're dropping this requirement, which effectively makes Avalanche kind of like a viable option to Cosmos SDK. So I think the Avalanche thing is called Hyper SDK. And so viable option to Substrate, Cosmos SDK. You could maybe argue Filecoin subnets. But Avalanche has more of a track record of that. There already are some subnets and so on. I looked into like the consensus protocol stuff that comes like bog standard in Avalanche a little bit, and I'm a bit confused about a couple things. There's it's like a DAG based chain kind of thing, like a leaderless consensus, but then there's a semi concerning amount of fallbacking to a leader in various different situations. But whatever, DAG chains are very difficult, and Sui and Aptos are like implementing reputation systems for their consensus to prevent all kinds of problems and so on. But my point is that do get a different kind of structure to build with. Like right now, Cosmos and Substrate are very particular choices that you need to make. Substrate may be like the most dramatic, because Substrate, if you want the benefits of interoperability and you want access to the ecosystem, you got to be a powerchain man and you got to give, Gavin money. This is a joke. You need to like buy a powerchain slot at an auction from the network.
So you need to pump Gavin's bags, not give Gavin money.
Exactly. Cosmos you can use very easily, and like that doesn't give you, you're not constrained to some specific business model, which is great for the people using Cosmos SDK and terrible for Atom the asset, which is the great irony of the Cosmos Polkadot race, is that like in some ways Cosmos is the clear winner. But it's the winner because it has no way of capturing the value. But adding another one into this, so like Avalanche is going to have a similar thing to kind of IBC or this subnet message passing bridge thing. And you can do slightly new kinds of things. You can, it gives you an out of the box consensus protocol that isn't Tendermint, that isn't, Babe and Grandpa. So I think that's quite exciting. I think there's actually a need for that. Maybe people are moving on to like, we're bored of L1s. We need new things. I personally think that there are still a lot of L1 things to be done. There are a lot of things that cannot be L2s because they are very difficult to verify on chain. Gebulot, what I'm working on personally, is an example of that. Arguably data availability is an example of that. Arweave is an example of that, like these types of things. And there's probably a finite universe of things that need to be L1, but I don't think they're fully explored. So getting more of those is great. Like, I think that is actually a helpful thing. And I think like there will be quite a lot of interest in people becoming a part of the Avalanche ecosystem, because it is like a big ecosystem market cap wise, which is, I don't know why, I don't know what all these people are doing, but that is compelling, right? Like tap into that, liquidity and like there's not that many things there for people with Avalanche bags to do. So you can probably make some like pretty enthusiastic fans and get some enthusiastic users from that community. So yeah, what do you think?
Well, when we discussed this, I think I was a little bit skeptical, not about the approach. The approach makes sense, right? But if I recall, my main reaction was like, wait, why would you actually use this, right? Why wouldn't you just go the Cosmos route? And you just mentioned the main reason, which is there's liquidity there. And we have a mutual friend who is a huge fan of the Avalanche consensus, not necessarily of the project itself. So maybe there are people who are attracted to the platform because of details like that. If nothing else, this is a lot more sensible than the things that Avalanche seems to have been trying up until now, including crapping on absolutely every other chain. So good for them. I mean, happy to see looking forward to see what comes out of this. It's not going to make me go out and back up the truck on Avalanche, but glad to see that they're trying something else.
Yeah, I wonder what this, because ostensibly this doesn't have a huge impact on value capture, right? Like the value capture of nodes needing to validate the main chain doesn't.
Yeah,
it's none there, right? Yet Avalanche is so much bigger market cap wise than Atom, so it's like it's fascinating to see how that kind of plays out and whether they'll try to, like, because this is obviously a very good thing for the developers, but then it doesn't, as far as I know, include any kind of value capture mechanism. Maybe you create some central point of liquidity on the main Avalanche chain or whatever, but But I wonder if they'll try to implement something later. I think arguably the Cosmos attempts at doing that have failed miserably in some sense. Like, it's very hard to afterwards be like, you know what, you guys, because you need to enforce it, otherwise everyone just opts out. So we'll see how that goes. This is a big like unknown thing, I think, in this industry still. Is like, okay, if you make the most popular, stack, does that mean you get any money? The Cosmos situation would indicate yes, some. Like, some people will just back you and you kind of immediately get a return on your work from that. But like, revenue wise, it's a bit unclear. Like, as far as I know, Osmosis actually kind of dominates Cosmos now, not Cosmos Hub. So it's a weird, like, it's a tricky game to play, because like, it is the altruistic sort of thing to do, but then you do like give up your ability to monetize it potentially.
Okay, so a couple things. Well, first, asterisk on Avalanche. If I'm not saying much about it, it's just because I guess I find this kind of thing relatively uninteresting. I find it interesting that they're trying this, but I basically, off the top of my head, I can think of anything that you would build in Avalanche that you couldn't build on other chains, by and large. So, whereas I do find the AO thing on Arweave interesting because it's different, right? And different. Yeah. I find different and weird. I find appealing.
This is more regular blockchainy stuff.
Yeah, it's just it's just a regular blockchain just trying a different way to capture people's attentions, which again, more power to them. But what you said about Cosmos, if you build a popular ecosystem, do you make money? I'm pretty sure that the Cosmos founders made out okay, right?
Well, this is what I mean, but not so because their network captured value.
Sure, right? But it's not. What I'm saying is, that this wasn't an altruistic thing
on Atom in the early days.
Exactly. But what I'm saying is that they're not going at this because of it's not truly altruistic, right? They just built something that doesn't benefit people who invest later on Atom, because there's fairly little returns on the token itself. That doesn't mean that they didn't make money.
No. So, like, to be clear, in crypto, you don't need to necessarily even build anything useful to make money. This is like,
which I'm sure will come as a shock to anyone who hasn't heard of dog coins.
Just to close off, I have this. I've noticed recently that people are getting on board the Solana train, right? Like, the EF is now talking openly about it. Like, yeah, Solana really kicked us in the butt, and that's why, like, it's good. We now need to like figure our shit out. But I've noticed, and this is, I think, like a personality trait that I uniquely have, is like, when everyone disagrees with me, I'm very convinced that I'm right. And then when everyone starts agreeing with me, I start getting suspicious.
You're worried that it's becoming a crowded trade.
Yeah, and also, like, there's a part of me gets suspicious and a part of me gets bored. It's like,
I hear you.
It's like, okay, like we're all in agreement. Solana is like clear winner of this cycle because it's the only thing that scales, is relatively battle tested, blah 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 blah. And then I talk to all these VCs and they all agree with me, and I'm like, okay, great. And then in the back of my mind, I'm like, oh fuck, the VCs agree with me. There must be something horribly wrong with this thesis.
Look,
when have the VCs ever been right?
Well, it's an issue of time horizon, right? The thing that might be wrong is that the VCs were. No, but also the thing that might be wrong is that the VCs who agree with you are starting to come around now, which wouldn't be the time that I start deploying like large packs of cash into the ecosystem necessarily, or at the very least into the main layer. But there was this It wasn't actually on one of Arthur Hayes' pieces where he had this sensational line about how the exceptional investor invests in heretical teams and then sells once those teams become orthodox. And seems like Solana is reaching orthodoxy now. So.
Yeah, though I think you want to ride the orthodox train into the end of the cycle, but
I would definitely agree. I'm not gonna go out and dump after this. Not financial advice to anyone, but again, I also would not be loading up right now, as we have discussed before. I'm great. The numbers going up. I'm great. People are coming around Solana, and just.
Yeah, these are always really tricky. So I like in the last. What am I saying? In every single bull market, people like. So this is okay. So definitely not financial advice. This is just my own experience, and it's like an interesting problem I have in my mind, where people will ask me if they should buy around and abouts when like I have started selling a little bit. And this is always the case. And this is partly because like I just want to like I've already gotten a multiple and I just want to de-risk a little bit because that makes it easier for me to then like ignore most of the noise. And when that question comes, I'm really hesitant to ever tell anyone to buy or sell, because if I'm wrong and they do it, like I just feel bad about it. But then at the same time, I'm inclined to like say something, because oftentimes the people are completely clueless. And so I feel like there's a fairly high chance that I am more correct than them on timing, given that they have been looking at the chart for 2 days and I've been doing it for a decade, or now almost 12 years. But there's a situation where like I'm fairly confident that prices will go up a lot higher, but I wouldn't buy anymore. Which is exactly kind of what you're describing, I think.
Yeah.
Is like I'm fairly confident right now that prices will go up higher, but I have bought at way, way lower prices. So I have this like huge risk margin or something like that. Like I'm like, I'll be okay if, prices only go up double from here.
Yeah, look, I've taken out my principal and then some. If this shit blows up to zero tomorrow, like, okay, not ideal, but I'll live, right?
Yeah,
Look, the
be a
only advice that
bummer, but
the only advice that I always give people in this case, which actually will do the same with when they ask me about, Apple's picking up or Amazon's picking, don't buy anything that you haven't at least tried to use. And if you try to use it and you can't use it, like stay the fuck away from that. Yeah, and if you start threatening it, you don't get it, like don't touch it. Like we are coming to the point where dog shit flies. You could probably throw money at coin market cap, and if you were lucky, you exit a point where you made money. But that's no sane way to deploy capital.
This is good advice, and I want to point out that like if you're a person who's like not paying attention to crypto most of the time, but you started paying attention when the token prices have gone up, bear in mind that when you notice they've been going up for a while, and that doesn't mean that they don't go up further necessarily, but the higher up in a cycle you buy, the more important it is that you time your exit. And I find that those people, like, they're just not very good at timing it. I mean, no one is very good at timing it, to be honest, which is why I don't really try. And I kind of operate on these pretty crude, like, multiples. But, like, just if you enter kind of once the bull market has started, then you're playing like a very specific, tight timing game. and getting out is difficult. Like it's a very risky kind of way to go about it, as opposed to buying in a bear market where you can be fairly confident that everything is cheap. Like you also feel like everything is probably going to end tomorrow for about 4 years, which is, psychologically quite difficult. But it's just something that continues to always happen. And of course, like, even though millions of people out there listen to this podcast, most of them will ignore this advice, and I'll start getting messages soon enough from all kinds of obscure people asking what they should buy. But I really haven't figured out. Like, I think your advice is good. I think I'm going to employ that. The other thing that I usually do is I tell them what I'm doing, honestly, but I don't give any advice. And given the timing usually matches up, it's usually I'm selling. Do what you'll do, but I'm selling.
And by the way, that advice goes more than double if you're a developer. The thing that kept me away from Polkadot was because I went through the
Oh, you mean the try it
substrate
advice?
and no, the thing, yeah, not to try this, to try the freaking platform, like find a tutorial for something and walk through it. Like the Polkadot substrate stuff, I couldn't get half the stuff to build. Shit didn't compile, files were missing. Like, this tells you something about how likely people are to end up building on that platform, right? If you are,
Well, there's also stuff that's early, right? Like it
I
depends.
disagree. No, I
Well, for
disagree. If
example, for the longest time, we couldn't get the main build of RISC-0 to build.
Sure, and then that means that at that point it's an
But
extremely
they did
risky.
have a nightly that we had when we once somebody told us which one, we did get a bill.
That's fine, and that would mean that at that point it's an extremely risky bet for people to take. When I invested on Solana, for instance, when I first started coming in way back when, I can't even recall what the name of the first wallet was, but it was like this shitty web-based wallet that was the only thing you could interact with, and it did work with Ledger, but it wasn't even like a Chrome extension. It was a website, and I could see most people not figuring that out. So therefore I would not recommend this thing to most people at the time. Right at the point that Solana gets some wallets that people can try, then that's different. Then and for developers, for instance, AOS is very early. I mean, literally they just launched the testnet, but you get through the
Arweave
tutorials.
Is pretty mature.
Sure, but you get through the AOS tutorials, and they're well reasoned, they're well explained. I could actually see a developer community coalescing around these things if they do a good enough job promoting it, right? If the tutorials were completely broken, then you can put all the cute Twitter videos out there that how are people going to learn how to build on this? They're extremely stubborn.
Yeah,
Try
I
stuff.
think I think this is right, but I mean, but let's also acknowledge that there are a lot of people who are not going to try these; are just going to buy them, right? Like as much as it would be good if they did, they're just not going to do that. Like, how many people who are buying Bitcoin ETFs are going to be moving Bitcoin around for real?
Fine.
Zero, right?
At which point they're on their own. I can help those people. If they might do well, they might not. That's
well, they're on their own, yes, but then they lose a whole bunch of money, and then we get the shit for it, right? Like, that's what happens. That's the classic crypto cycle. Regulators
not me personally.
up in arms. Well, the industry, the sort of permanent industry, the civil service of crypto, the deep state.
No, I don't. For what it's worth, I don't think that's true. The regulators don't come in when Bitcoin price goes down, because Bitcoin has crashed significantly before regulators came in. The regulators come in when there's a very visible blow up due to something utterly stupid like Terra Luna. That's when they start looking at, like, someone ought to do something about this, because this things can be allowed to to continue, right? The regulators didn't come down where Ethereum price has crashed a few times. Like nobody cared, if people are investing on it. It is when you get I think it is when you get the wipeouts, basically, that they start coming in. And that's what happened in Luna. That's what happens with the rug pools. Security crashes. The security crash, like lost 30%. Like that's your thing. You're investing in something risky. The end.
Yeah. I think it's a combination of both. Like I do think there is an element of people. So if you think about kind of like the way that regulatory pressure usually goes, it's like, okay, something happens, a large enough swath of people start making noise about how they feel that this was not fair or legal or whatever. There should be blah, blah, blah regulation. That puts pressure on the regulators to do something. Large swaths of people losing a lot of money certainly doesn't help, right? Like at least it doesn't create any defenders for us.
The Bitcoin ETFs are regulated, aren't they? I mean, that's the whole point.
Well, yeah. Well, okay. We don't need to get into that. Bitcoin ETFs are regulated, and yeah. I mean, yeah. It's a funny little trick. I mean, it's yeah. It is kind of mind-boggling when you think about it that actually went through. I mean, people were talking about Bitcoin ETFs 10 years ago. The fact that it was allowed to come into existence is kind of insane.
That could be an episode on its own, so I'm not going to start rambling about it.
Well, we'll leave it there. Thank you, everyone, for watching, and see you next time. Ciao.
Ta-ta.